Today we are going to do another mixed number word problem. Gino was 36 and 5/8 inches tall in kindergarten. She is 50 and 1/4 inches tall in 5th grade. About how many inches taller is Gina in 5th grade than she was in kindergarten? So how many inches taller? That's going to be a subtraction problem. Right? So we're subtracting how much she was in 5th grade because we're finding the difference from how tall she was, or we're subtracting what she was in 5th grade minus what she was in kindergarten. Now, this is a pretty straightforward problem, but one thing I want to point out about this is the numbers of the mix number is quite big. So this kind of solidifies, or I guess shows the reason why I prefer not to convert these numbers into improper fractions to subtract them. Because in this case, you're dealing with very large numbers, right? So I would be getting numbers that are in the hundreds in these fractions, and something like that might be very hard to reduce and things like that. So I just feel like it's easier to not to just borrow if we have to. So in this case, we have the 4 and the 8 are denominators, so we need to find a common denominator. Now I know 4 is a factor of 8, so I have to think, what do I have to multiply 4 by to get 8? And the answer is 2, so I multiply 1/4 by 2 over 2, and then it equals 2/8. And then I have 36 and 5/8, so I'm going to subtract minus 5/8. But, oh wait, I can't do 2/8 minus 5/8. So I have to borrow from this 50, make it a 49, and then I'm going to add 1 to this fraction, but in fraction form, so it would be 8. I'm adding 8 over 8, so it's 49 and 10/8 minus 36 and 5/8. So I'm going to do 10 minus 5 equals 5/8, and then 49 minus 36 equals 13. So the answer is 13 and 5/8 inches taller in 5th grade than she was in kindergarten. That was pretty straightforward. Now, if I wanted to multiply this, or do this into mixed numbers, let's just say I wanted to convert this into mixed numbers instead of using the borrowing method of subtracting, I would have to do 50 times 4, which is pretty easy. I know 5 times 4 is 20, so 50 times 4 is 200 plus 1, so that would be 201/4 minus 30. I have to do 36 times 8. 8 times 6 is 48. 8 times 3 is 24. Plus 4 is 28. So we have 288 plus 5. for what's in the denominator, so that would be 293 eighths. Then we need to convert this into eighths, so we need to multiply both top and bottom by 2 over 2. 201 times 2 is 402 over 8 minus 293 over 8. So now I do 402 minus 293. I have to borrow from here. The 40 turns to 39. 12 minus 3 equals 9. 9 minus 9 equals 0. 3 minus 2 equals 1. So we're at 109 eighths. Now we have to convert that into a mixed number. So I have to divide 109 divided by 8. 8 goes into 10 one time. So minus 10 minus 8 is 2. 29. 8 goes into 29 3 times with a remainder of 5. And that means that we have 13 and 5 eighths. As you can see, we still got the same answer, but I just wanted to mention that you have to do all of this math, right, with these much bigger numbers that can just be avoided if you just use this method over here. So that's why I prefer the borrowing method, but I just wanted to point out that you can also use the change it to improper fractions method, but sometimes it just makes things much more complicated and have more steps and you have to use bigger numbers. So hopefully that was helpful.